Good morning, students. Today we shall continue with the chapter Complex Numbers and Quadratic Equations. And today's topic is Properties of Multiplication. The way we have carried out properties of addition in the same manner will go with multiplication also. So let's consider two complex numbers Z1 and Z2. So multiplication in any order of these two complex numbers is possible. That means Z1 multiplied by Z2 is equals to Z2 multiplied by Z1. That is commutative property. The second property is associative. We call it associative law also. Multiplication in any order. That is for three complex numbers Z1, Z2 and Z3 is possible here. So Z1 multiplied by Z2 in bracket multiplied by Z3 and Z1 multiplied in bracket Z2 and Z3. Both possible values will be same. Okay, so the answer for the left equals to answer for the right. And the third property is multiplicative identity. The multiplicative identity is 1. So Z multiplied, the complex number multiplied with 1 will always give you the same complex number Z. Okay, and this is commutative in nature, 1 into Z. Here 1 is the multiplicative identity of an element or the complex number Z. Fourth property is multiplicative inverse. Every non-zero complex number Z, there exists a complex number Z1 such that Z multiplied by Z1 is always equals to 1. So if I have a complex number Z and its multiplicative inverse is written as 1 by Z, or we can write it as Z power minus 1. So Z multiplied by its multiplicative inverse will always give you 1. So if you multiply here itself, Z get cancelled, the result is 1. And the most important property is distributive law. So we are trying to distribute multiplication over addition. Z1 multiplied with Z2 plus Z3. So Z1 is going with Z2. So Z1 Z2 and then plus sign. Z1 multiplied with Z3. This is called as left distribution. For the right distribution, it looks like this. Z2 plus Z3 multiplied by Z1, Z2 Z1, so Z2 Z1 and Z3 Z1. This is called as right distribution. Division of complex numbers. Let Z1 equals to X plus IY1 and Z2 equals to X2 plus IY2 be any two complex numbers. Then their division is Z1 by Z2 is X1 plus IY1 and X2 plus IY2. So over here we'll be writing and we'll be using an equivalent method where we multiply the numerator and denominator by the conjugate of the denominator. That is x2 y1 minus x1 y2. Here if you see what exactly has been done, if you multiply this by x2 minus iy2 by x2 minus iy2, the result is x1 x2 plus y1 y2 plus I x2 y1 minus x1 y2 upon, this is a plus b and a minus b, so this becomes a square minus b square, the identity, so that becomes x2 the square plus y2 whole square. So remember here the z2 needs not to be equal to 0. If it is equal to 0, then the result will be non-defined. The second last topic for the day is conjugate of a complex number. If z equals to x plus iy, that is a complex number, then conjugate of z is denoted by z bar. Okay, z bar. So if z equals to x minus iy, that is z bar equals to x minus iy. We have seen the conjugate example in case of the division. Okay, here this is the conjugate of x plus iy1, x plus iy2, sorry. So here properties of conjugate. The conjugate of the conjugate will always give you the same complex number. All right, so z equals to x plus iy, and if you find the conjugate of this becomes x minus iy, and the conjugate of this conjugate will be again x plus iy. All right, so this is how it works, the first one. Second one is z plus z bar, that is the complex number plus its conjugate is nothing but z, which is purely real, and z minus z bar will give you purely imaginary number. So RE, that is real z, equals to z plus z bar by 2, and imaginary z equals to z minus z bar by 2i. Conjugate of the sum of two complex numbers z1 plus z2 will be giving you z1 individually in separate, z1 conjugate plus z2 conjugate. Same goes with differences also, and with multiplication also, and with division also. Here z2 is not equal to 0. If it is equal to 0, the result will be not defined. Modulus of a complex numbers. If z equals to x plus iy be the complex number, then the modulus or magnitude of z is denoted by mod z and is given by mod z equals to x squared plus y squared. This is x squared plus y squared. It represents the distance of z from origin, that is mod z. We'll learn in the next part of the complex number, the eigenplane. In the set of complex numbers C, the order relation is not defined, that is z1 more than z2 or z1 is less than z2. Has no meaning, but z1 mod of z1, if we are writing more than z2, mod of z2, or z1 less than z2, has got its meaning, since mod of z and z2 are real numbers. Properties of why it is real numbers, because we are nothing but doing the squares of the real numbers, of the complex numbers. Okay. Properties of modulus. Mod of z is always more than equal to 0. If mod of z equals to 0, then z equals to 0, that is real z equals to 0, which is equals to imaginary z. Minus of mod of z is less than equals to real z, less than equals to the mod of z, and minus mod of z is less than equals to imaginary z, less than equals to the mod of z. Mod of z equals to mod of z conjugate equals to mod of minus z equals to minus mod of minus z conjugate. Z into z conjugate equals to mod of z square. Alright, z into z conjugate equals to mod of z square. This can also be proved. And mod of z1 into z2 individually we can write the way we did for conjugate also. In the same manner we do for the multiplication as well as for the division. So these are the properties of the conjugates and modulus. You can try by working on certain examples which is given in the example section of your NCERT book. Reciprocal multiplicative inverse of a complex number. Let z equals to x plus iy, again the complex number. Then the multiplicative inverse z bar, that is z minus 1, not z bar is the modulus, that is the conjugate. So z power minus 1, that becomes 1 by z. So there it becomes 1 upon x plus iy. So we multiply by its conjugates. These are the conjugates of x plus iy. So x minus iy upon x square plus y square, obviously. And when we separate it in the form of a plus ib, it looks like this. So x by x square plus y square plus iy, okay, minus, here it should be minus first of all, x by x square plus y square minus iy by x square plus y square, and then changing the sign here to make it plus in the standard form a plus ib, the sign will go to the real part, that is y. Okay, and this is what this is how it looks for the reciprocal of complex number z. So where z power minus 1 is called the multiplicative inverse of z, or simply we can write 1 by z also, that will also work. So that's all from today class. Thank you.